Alright guys, in today's lesson, we're going to be looking at a concept called the fundamental counting principle. Alright, so the fundamental counting principle, what this tells us is if we have one event that can occur a number of ways, we'll call that M, and we have a second event that can occur another number of ways, we'll call that N ways. The number of ways that the two events can occur in a sequence one after the other would be M times N. Now, this doesn't just work for two events. This can be extended for any number of events, whether it's 2, 3, 4, any number of events. All right, so let's look at an example. Say we're going to purchase a new car. Okay, so we've got three possible manufacturers, Ford, GM, and Honda. We've got two car sizes, compact and midsize. And then we've got four colors, white, red, black, and green. So if we want to look at how many different ways, just like one manufacturer, one car size, and one color, and then we're going to use a tree diagram to kind of check our results. All right. Well, since there's three choices of manufacturers, two car sizes, and four colors, the fundamental counting principle simply tells us we multiply 3 times 2 times 4, giving us 24 different ways. If we look at the tree diagram, you can see in our first row, we set up the manufacturers. Then down from each one, we set up the two types of car sizes. And from each one of those car sizes, we set each of the four colors. If you look along the bottom row and you counted those up, you'll see that there are 24 different outcomes. Okay, let's look at a second example. This one now we're going to be looking at an access code for a car security system. It consists of 4 digits. Each of these digits can be any number from 0 through 9. Okay? Well, the numbers 0 through 9, those digits, there's 10 of those. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay? We're going to look at 3 different scenarios. We're going to look at one where each digit can be used only once and we can't repeat it. The second one where each digit can be repeated, and the third one where each digit can be repeated, but our first digit cannot be a 0 or a 1. All right, let's look at that first scenario where each digit can be used only once and not repeated. Well, since it cannot be repeated, on the first digit we have 10 choices, but then it goes down by 1 because one of those choices is eliminated, so we have 9 choices for the second. Goes down by 1 again because we eliminate 1. We have 8 choices for the third digit. And then we take that digit away and we now have 7 choices for the fourth digit. So our fundamental counting principle tells us we can multiply 10 times 9 times 8 times 7. We punch that in the calculator, we'll get 5,040 possible access codes. Okay, let's look at our second scenario where each digit can be repeated. Well, since each digit can be repeated, then there are 10 choices for each of the 4 digits. So all we simply have to do is 10 times 10 times 10 times 10, or 10 to the 4th because there's 4 digits, and that gives us 10,000 possible access codes. All right, let's look at our third scenario where each digit can be repeated, but our first digit cannot be a 0 or 1. Well, since we're eliminating 0 and 1 for the first digit, that leaves us with 8 of the 10 choices for the first digit. The other 3 digits, we still have the full 10 choices. Okay, so we multiply 8 times 10 times 10 times 10, which gives us 8,000 possible access codes.